Hey guys, so it's Saturday, the 3rd of October, which means time for the third Leetcode October challenge, which seems to be named K-diff pairs in an array. I'm Victor and I will be solving this in a raw unedited format. So main goal for this video series is for me to be able to go back and see my thought process. So potentially in a year or two, I can come back to these videos and hopefully see some progress. Since disclaimer here, I'm not a competitive programmer. I'm not any sort of algorithmic expert. I'm just your regular person who loves tech stuff, who's working a job as a software developer, but doesn't necessarily get to solve many of these problems in the real world. So yeah, without further ado, let's go to K-diff pairs in an array. Given an array of integers, code nums, and an integer k, so I have an array and an integer, return the number of unique K-diff pairs in the array. What does K-diff mean? A K-diff, oh, it's this, okay. A K-diff pair is an integer pair, nums I, nums j, where the following are true. So I have a bunch of conditions. So 0 is less than or equal to I. So I is bigger than or equal to 0, okay. And j is less than or equal to nums length. Oh, it's just less than. I mean, so this basically means that they can be the same. Okay, but the second one says they cannot be the same. This just says that I is bigger than or equal to 0 and j is within the upper bound of the array. So potentially I can be outside of the array. What does this, is this true? What is a? Why do we suddenly have an a here? I'm really confused. A less than or equal to b, and b minus a equals k. Okay, so they can be the same number. If k is 0, for example, they can be the same, and b minus a equals to k. Okay, maybe through the examples I'll understand it better. So we have 3, 1, 4, 1, 5, k is 2. Output is 2. Why is it 2? Because there are two diff pairs in the array, 1, 3 and 3, 5. Although we have two ones in the input, we should only return the number of unique pairs. Okay, so that's interesting. Does this mean that we actually do not care about the fact that it's an array? So the numbers, okay, so I and j are the indices and a and b are the numbers. I think I get it here. I think it's not the best description, but maybe it's good enough for someone who does this more often. So the numbers b is equal to a or bigger, and b minus a is k. So b is always the bigger one, or if they're equal, it's equal, okay? And b minus a equals k. I guess this means that k cannot be negative, right? Since if k is minus 1, then we can never have this condition true. Since if they're equal, then k has to be 0 for this to be true. And if b is bigger, let's say a is 1, b is 2, then 2 minus 1 is 1. But we can never get 3 minus 2, which would be a minus 1 for k. So implicitly, this means that k is not an integer, it's a positive, a non-negative integer, since it can be 0, probably. Yeah, it can be 0, but it cannot be negative. Okay. So there are two diff pairs, 1, 3 and 3, 5. And here, oh wait, it's ij here. Oh, it's in the same row. So okay, so both of them can be they're within bound. Both of them are within bound. I don't know why I saw this first and this second, and so they're separate. So both of them are guaranteed have to be within bound. So from 0 to less than length of the array. Okay, not off to a good start. And they're not the same index, but they can be any. So like it doesn't seem like it's necessary that j or I or j is first, like RB is first. Doesn't seem to matter. So they're taking 1 and 3, and they're taking 3 and 5. So I think we immediately don't care about duplicate numbers, but we do need to know the index since we are... Oh, do we? No, we don't need to know the index. Actually, even though we have this as a pair, we don't care about the index. But we might care about having 2 ones. Let's say if it's 0, yeah, this is the case that I was thinking about. If k is 0 and we have 2 different ones, then 1 minus 1 is 0. So we do need to care about this. We cannot just take it as a set or something. Okay. Does it only matter when k is 0? I think it only matters when k is 0, right? Because if k is 1 or k is 2 or k is any other number, we should never care about duplicates since they don't bring us any value. We're only really using them once. So we can have like a special case. If k is 0, we basically need to find the duplicates. If k is not 0, we need to find 2 numbers such that one minus the other equals 1 or 2 or whatever k is. Okay. We have some constraints here. 1 is less than or equal to number's length. So we always have at least one number, and it's within some reasonable upper bound. So this means that they're integers, I think. I never seem to remember what max integer is. Actually, can I just check what 10 on 7, 10 power 7 is 10 million. Okay, so this is like relatively small integers. Okay, and I mean, yeah, I could just have put 7 zeros here and never mind. I guess it's not the best to solve problems late at night. Okay, and k itself is within the same. Okay. So, okay, for k0, we have an algorithm. Basically, find any pair. Find any duplicate number. This is all I need. If k is 1, then I need to find any 2 numbers such that their difference is 1. Doesn't matter where they are or how they're presented. We can have negatives though. I guess in this case it's case 1. So 2 minus minus 3 is like 1, and 1 minus minus 2 is 1 again. Yeah, they can be negative. So if it's 1, we need any 2 numbers such that one minus the other is k. So if we start from here, like let's say I'm reading this list. Do I need to deduplicate it if k is not 1? It might help. So let's say I deduplicate it, which should be something like O of n, because I can create a set and then put every number once, which is n times O of 1, which is O of n. I deduplicate if k is not 0, and I can do like the reverse of deduplication, kind of. I just need pairs. Anyway, for k is not 0, I deduplicate it, and then I start. I have a minus 1. Can I not check for every number, every other number? So let's say if on one pass I come here and say, how much do I need to deduct from minus 1 to get a 1? The answer is minus 2. Then I come here and I say, how much do I need to deduct from minus 2 to get -1, well, -3. And I come here and I say, how much do I need to deduct from -3 to get a 1? Well, -4. So now I have like a temporary helper array that has the values I'm looking for, which is -2, -3, and -4. And then I start from here, and do I need to keep it in an array though? Since I don't need to know the indices, I just need to know that this is what I'm looking for. So I can have a set with those three numbers, -2, -3, -4. And I can go again through this list. Is this contained in the set? No. Is this contained in the set? Yes, output +1. Is this contained in the set? Yes, output +1. So then I get output 2. Do I need to deduplicate here? I don't think I need to deduplicate. If I create a set just to keep my helper numbers there, then the set will already deduplicate it, and I just need to make sure that if I use a number in the set, I remove it so that I do not get two results at the same time. So let's see if I can write some very simple algorithm. And also make sure my camera is not blocking anything this time. So I have let's just take an easier number. Let's take this one, which was supposedly, it has more cases, but whatever, it's easier. So parsing this list, I create a set that contains so 1. How much do I need to deduct from 1 to get a 1? So 1 minus x equals 1, x equals 0. So I get a 0 here. And then on the 2, I get a 1. Then on the 3, it's -2. Then on the 4, it's -3. And then on 5 is -4. So I have this set. And then I go again through the same list. And I ask, first step, is there a 1 in the set? Yes. So this is my index 0. Is there a 1? Question mark. Yes. So I get my set. And I have somewhere solutions, which is 0. So on this, I do, after this step, I'll have solutions equal to 1. And then I go to the next index. And then I remove the 1 in case I had another one. Let's say this is my list. I'm just gonna I'm gonna write it like that, and then if I go back to my initial set, if I attempt to say 1 minus x is 1, x is 0, so then I'll say put 0 in the set, but it's already contained, so I'm not gonna change anything in the set. So I don't care about any further deduplication. Great. Some lovely grape juice. Okay, so my I is 1, which means I'm on the 2. Is there a 2? Yes. So this means, again, I remove the 2. I have two solutions. Index 2. Is there a 3? Yes. So again, solutions is 3. I is 3. 3 is removed. Is there a 4 in the set? Yes. Again, solutions are 4. I is 4, and the 4 is removed. Is there a 5 in the set? No. So again, I keep it like that, and then I ask, is there a 1 in the set? Well, I removed it in the first step, so no, there is no 1 again. So I have 4 solutions. This seems to be the solution. Yeah, so I guess I skipped the brute force. The brute force solution that I was attempting not to even think about would have been to check for every number, every other number. Okay, so I think I have a solution now. Let's get to coding it. I guess I'll still use IntelliJ, since I prefer using IntelliJ. And I'll take this, I guess I just need the function, don't need the class here in Kotlin. So cool to write in Kotlin because of small things like this. Oh, and I need the case for K0. K0 is much different though, right? Is it different though? If I create the set, let's just check some very small example. If I have this and I say K0, do I need to write separate code, or can I just reuse my existing code, since I kind of thought it's different, but it might not be. So let's say I have just this to make it easier. So I again, this is k equals 0. I create my set. 1 minus x is 0. Well, set of 1. 3 minus x is 0. Well, 3. 1 minus x is 0. Well, 1 again. But I already have it, and set does not contain duplicates, so I'm fine. And then I'll say I equals 0, solutions equals 0, I equals 0. Is there a I equals 0, I said. Is there a 1? Question mark? Yes. So my set is 1, 3. So this means on my next iteration, solutions is 1, I is 1. Is there a 3? Is there a 3 in the set? Yes, there is a 3 in my set. So this would not work, since I do have a 3, but it's not a valid solution because I'm not honoring I is not equal to j rule. I need to honor the I is not equal to j. So I think I don't need to care about I is not equal to j in my other example, because since in the same spot in the array I cannot have both. Let's say k is equal to 1. I can never have both 1 and the 2 in the same memory address. They have to be different memory addresses, so I don't need to care about it. But in the case of k0, I very much need to care about it. So in the case of k0, I mean, I can make a very hacky solution that would be quite fast in runtime. Like, I can do it in a single OFM pass. So let's say I just keep a map of int, which is a map of the key is number, and it doesn't even need to be an int, it just needs to be a boolean, which is matched already, since we don't want to, if we have like something like this, we only want to count 1 and 1 twice, we don't want to count it 3 times. So instead of creating the set, what I would do is I would create if it doesn't exist, so let's say my index is 1, my map is empty, so I'm just gonna put in the map the pairing 1, because 1 minus 1 would be the 0, and then false, since it's not matched yet. And then on I equals to 1, I would create 3 and then false, and then the next one I would create again I equals to 2, so this is the 1. I would see that I already have a 1, and I would say 1 true. And then, I mean, I can even keep a solutions equals to 1. I mean, I don't have to, since I can always just go back through the entire map and count the truths, but I don't have to, since I can already compute it here. And then the next time I see on my next one that there is a match, so my I is 3. Since I already have a match, I can just see that it's true, and I can skip adding it again, and I would have a single solution. Can I do this? I mean, I can generalize this, right? Since I'm using a set here anyway, I can just use a map, and I would kind of not care about this logic, about asking for the true or the false, whether it's matched already or not. Oh wait, I can just, you know, in this set, I'm removing the elements. But instead of removing them, I can just keep the true or false pairing there. So instead of removing them from a set, I'll just keep the true or false in the map, so I can have a unified solution for both cases. Okay, I think this will work. So let's try to code it. I think it's also reasonably fast. Actually, what would be the time complexity of it? I guess I'll explain time complexity when I get to coding. So, what do I need to do first? I have these nums, so I have to go once and wait. It's still kind of different though, isn't it? Because in the case where in the case where k is 0, I need to do it in a single pass. In the case where k is not 0, I most definitely cannot do it in a single pass. Because imagine I have here the -1, -2, -3. So if I have it in this particular order, -1, so I cache that I would need a -2. Then I find the -2, but imagine that they were reversed. So let's say they're -3, -2, -1. So if they were reversed, -3, -3, -2, -1, and I do it in a single pass, then I would say in my set or map or whatever, I need to have, and here k is 1, I need to have a -4. Okay, well, if I continue in the single pass, then on the next index, I would say, well, okay, are you a -4? No. What do you need? A -3. And I already missed the -3. So this should have been a solution, but it's not a solution anymore. So I cannot use the same approach. And in the k equals 0 case, if I first create my map and then go again through those solutions, then 3 would be a solution, and it's not really a solution since it doesn't have a match. How can I ensure that this doesn't happen? I mean, I can probably sort them in some way, but I would prefer to not sort them if possible and have a unified flow. So I'm just gonna think a little bit more about this. 1, 3, 1, 1. I mean, my pre-processing would work here just fine. Can I keep a pre-processing for K0 as well? I guess instead of a boolean, I can just count the number of occurrences and then go through my map, which is again O of n at worst. And just my solutions are every mapping that has above 1. So in this case, I would have like a map of instead of this, I could have a map of 1 that is encountered 3 times and 3 that is encountered once, and I would count this as a single solution. And in this one, let's imagine that this is not a set. This is a map. So in this case though, I don't need to match them. Matching them a single time is okay. So in the 0 case, I need them to match more than once, since once means that they are not they're not a pair, so they do not equal to 0. But in the other case, In this case, I have 1, 2, 3, 4, 5. So I need 0, 1, 2, 3, 4. So that 1 minus the other is 1. In this case, if I find a single 0, then it's fine. But if I write it this way, I can reuse my logic, and then just on k equals to 2, I can pass to some method to extract from the map everything that has more than 1, and in the other case, everything that has more than 0 matches. And then again, I'm protecting myself. Instead of removing them from the set, like I was doing in this example, I'm just gonna add a counter. Okay, I think this is not the worst. I'm sure there is a much better solution, but I think this will work just fine. Okay, so let's write my algorithm. So I need to get first this map. So I'll have a what is it? Reminders. How do I write this word even? Remainers. I guess I tried to autocorrect it. Reminders. Okay, so nums to look for. So this would be create my nums to look for, and now I need to pass nums and k. So this is some method that I'll implement. That this will be of type map int. And again, this is key number to look for, and then value is number of times and countered. Wait, I'm confusing myself again. I needed to do this on 2 passes, right? So on the first pass, I find all numbers I'm looking for, and on the second pass, I find how many times they're contained. Oh yes, the method can do the 2 passes, right? That should be fine. Oh, I could also extract a set and then create a map from it, but whatever, let's keep it as that. So assuming we have this, then based on k, I'm just gonna say val min to min matches count min matches is equal to if k is 0, then it's min matches exclusive. So if k is 0, then min matches is more than 1, else it's more than 0, right? So if I have a single match, then it's fine if k is not 0. If k is 0 though, I need 2. I need at least 2 of the same number. And then I'll just say so nums to look for I guess I can filter it dot value bigger than min matches exclusive, and then count, and this would be my result, because on this line I remove all of the ones that are not considered a solution, and I'm just counting all of the solutions. And I just need to implement this method. Oops. Which would have to do it in 2 passes. So in the first pass, I'll just create a map where all the numbers I see and the zeros. So my map would be, so I have a mute val answer is a mutable map of int, and then on my first pass, I just write everything as with numbers encountered 0. So on my first pass, I'm just gonna say, couldn't I just create it as a map? So, oh, whatever. On the first pass, so for val num in nums. Well, I guess it's in. Okay, so for num in nums, I'll just say answer dot so val difference is what we're looking for is some number just a second. So what we're looking for is some number that current number minus this number equals 1 equals k. So current number is num minus the number I'm looking for equals 1. So the number I'm looking for equals k. So num minus x equals to k. So x, if I turn it around, it will be a plus x and this will be a minus k. So x equals to num minus k. So it's num minus k. And then I'll put in the answer diff and a 0. This is my first pass. So this is basically creating the set and deduplicating them, since I'm using them as a key in the map. And then the second time, I'm just gonna say for num in nums, if the number is not an answer, I don't really care. So I only care for the case where if answer num is not no. So here I'm using the difference as a key, and here I'm using the number itself. I think this should smartcast it to not knowable. Then I'm just gonna say answer num plus plus. Answer num equals to answer num plus 1. Why doesn't it want to do this? Knowable receiver. I just told you that this is not no. What? I mean, this sucks. I know for a fact that this is not no, but the compiler is not happy. Oh, I'm okay with writing the exclamation marks if I'm sure, like literally on the line above. So if there is such a potential, like here I'm having the answers, so I'm saying I have encountered the answer. And in the case where k is 0, I'm gonna count itself once. So this is why I need to find at least 2 matches. This is why above 1. And in the case where k is not 0, then a single match is okay, since this is the difference. This is not the num, and it's never the same as the num. Okay, and then I return answer. So can I test it with something? Do we have some samples? Oh, I can use just these samples. This is a long one. It will be a very fast. It will break it very fast if it doesn't work. Find pairs, and I need to say int array of this, and the k is 3. So south, and expected answer is 2. And I guess I want to try the negative one with k1 and the one where k is 0, if it works as I expect. The negative one had 2 and the zeros had 1, so it's 2 to 1. This one has 4. Let's try it as well. Control D. So 2 2 4 1. I guess it works. This can be a private one, but it doesn't really matter. For the purpose of solving the problem. Run code. Submit. Okay, so let's check our runtime for everything we do. I can keep this. So first we do this method. I'll go inside the method to check it a bit later. Then here, this is O of 1. It's just a single if, so it's always constant. And then this here goes once through my map. My map, at the worst case, where I have a bunch of different numbers, is every single number, so the nums is my map. So filtering means go exactly once through it. Can I say it's stream? Well, not stream, but sequence. This should be absolutely the same, but would hopefully make sure that this is a single operation, so don't do it twice. But it doesn't matter for my runtime. So this is O of n. And my method here is basically going twice through the number list. And then for the first time it goes through the number list, it calculates something. So this is O of 1. This is just a single operations regardless of the number of elements. And again, this is setting a key in a map. So this is O of 1. At least amortized cost. I cannot pronounce this word. Then again, for num in nums, this is O of n. So this would be basically twice O of n. So this is O of 2 times n, and in the end we have O of 2 times n plus O of n, which is like O of 3 times n. And since 3 is a constant, we can just say we have linear time. So this is the time complexity, and my space complexity is creating this map. At the worst case is O of n. So it scales based on the number of elements. As I mentioned, if all the elements are different, then and then is well, I guess for any n, if all the elements are different, this map is the size of my input array. So it's the number of my input array. And this one doesn't matter. It's O of 1. This one is just traversing the map, so it doesn't need any additional space. So my space complexity, so basically time O of n, space O of n, where n is the number of n is nums.length. Oh, that's it. I guess it took me quite a while, 38 minutes. Hopefully my initial struggle and thinking about the question is helpful to somebody. If it's not, well, hopefully it's helpful to myself next year or the year after to see if I have had any progress. So this was problem number 3 from the Leetcode October challenge called K-diff parsing an array. Maybe I can just very quickly check. Oh, I cannot view the solution. Is there like aren't there like a discussion panel or something like there was in the regular questions? Go to discuss. Super simple and clean solution. Not super fast, but super simple. So the super simple, he has a map, he has a K-diff pairs. He goes to the map. If k is bigger than 0, does something. This is basically the same solution I have. That's nice. This is a set of integer unique. This is a set of string pairs. For num in nums, if unique contains this minus this, pairs add num. What? Why is it a string? Why num minus k? So this is the pair plus this plus num. Unique add num. Well, this is not the worst. I mean, this is not a bad solution for that this guy has, assuming that it works. I think it works. Could it be reversed? Like, could this... does it work for... Oh, he's sorting them first. Yeah, that's why. So this is why his solution is a bit slower. So he still needs O of n time, or O of n space, but because in order to simplify his solution, he has to sort the array, he has to use n log n time on the input data. So his solution is a little bit slower. But it looks pretty neat. Okay, cool. Well, I think our solution is okay then. Yeah, so that was it. My name is Victor, and hopefully this was helpful to somebody. See you again tomorrow.